All right, and in this part we're going to practice using the quadratic formula, which I've written here. If you are planning on taking 3U math next year, I would like you to also watch the video on the development of the quadratic formula and make sure that you understand how this quadratic formula comes about, how it's actually made. All right, solve the following equations using the quadratic formula. You always want to make sure that you get 0 on one side, just like we did before with solving by factoring. You want to get 0 on one side of your equation, of your equal sign. So I'm going to subtract 2 from both sides, and then I have my equal 0. So now I can state my value of a, b, and c. So the a is the thing in front of the x squared, the b is the coefficient of the x, and the c is the coefficient, the constant term. So then we can say x equals negative b, which is negative 6, plus or minus the square root of b, which is negative 6, squared minus 4 times a, which is 5, times c, which is negative 2, all divided by, make sure that that line covers the entire numerator, all divided by 2 times a. All right, a negative times a negative, or negative 6, will be positive 6, plus or minus, I'm going to put that in the calculator, minus 4 times 5 times 2 negative. Okay, I got a 76 under that square root sign, and that's all divided by 10. So we could do the plus part. Didn't leave myself quite enough room here. So square root of 76 is about 8.7. I'm going to add 6 to that, get my answer, hit equals, and then divide by 10. And that gives me 1.47 approximately. 1.47. Or we have the subtraction part. 6 take away the square root of 76 divided by 10. Hit that equal sign, divide by 10. I think I did that correctly. I got a negative 0.27. I may have hit the wrong button on that, but hopefully that's correct. Negative. I'm just double checking my work because I don't like to make mistakes. There we are. All right, so there we have it. We've got our two x-intercepts if we were talking about the related quadratic function. All right, try the next one, maybe B and D, see how you get along with those. C, you're going to have to actually expand, simplify, get everything to one side on that. All right, so for part B, A is equal to negative 3, B is equal to 1. The coefficient of the x is 1, and C is equal to 2. So x equals negative b, so negative 1, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. That's going to equal negative 1 plus or minus the square root of, and I got a 25 under the square root and negative 6 there. Square root of 25 is a perfect, 25 is a perfect square, so that's just going to be a 5 there. Our x values will be negative 1 plus 5 divided by negative 6, which is, that'll be a positive 4 over negative 6, or negative 2/3. You could take that to a decimal, but I'm just going to leave it in fraction form, so I don't have to worry about that decimal. Or we have negative 1 minus minus 5, which is negative 6, divided by negative 6, which is positive 1. So we have our two answers of negative 2/3 and a positive 1 for that one. All right, part C, we're going to have to actually expand and simplify this and get everything to one side. So a little bit more work with that, and you'll find that with one of your homework questions. You're going to have to do some work before you can actually go into quadratic formula. Your A here will end up being 4, your B is negative 3, your C is negative 7. So all I did was multiply the x through that bracket and then subtracted 7 from both sides. So x will equal negative b, which is negative 3, plus or minus the square root of negative 3, which has to get squared. So the negative's getting squared, so you need the brackets around that, minus 4 times a, which is 4, times c, which is negative 7. I drop the negative there, all divided by 2 times 4, 2a. So that's going to be a 3 plus or minus. So that'll be a 9 minus. So that gives me a 121. And that's all over 8. And again, 121 is a perfect square here. So we could have, we can just write that as an 11. So our x will equal 3 plus 11, which is 14 over 8. 14 divided by 8 in lowest terms would be 7 over 4. Or you could take that to a decimal. Or x is equal to 3 take away 11 divided by 8, which is negative 8 divided by 8, which is negative 1. All right, there we have it. Now we've got this last one to do, which I've kind of encroached my other answers in that space. So I'm just going to switch colors just so you know which one's which here. So our A, B, and C will be 2, negative 4, and 9 respectively. So our x will equal negative 4 plus or minus the square root of negative 4 squared minus 4 times 2 times 9, all divided by 2a, 2 times 2. So that's going to be 4 plus or minus the square root of 56. Oh, wait, that's a negative 56. Ooh, shebang. All right, if you have negative 56 on your calculator and you hit this square root sign, you get an error. And my calculator just has E. E stands for error. Some calculators will actually say error on it. We cannot square root a negative number in the real number system. So this means this one has no solution. So if I were to graph the related quadratic equation where I had y equals this stuff, this will be a parabola that opens up, but it never dips low enough to ever cross that x-axis. So it will have no x-intercepts. There's no solution to this one. So that's an important piece of information that you need to make sure that if you get a square root and a negative number under that square root sign, you cannot do that in the real number system. There is another number system where you can do that, but we don't get into that in high school. All right, so let's put this into play to solve a word problem here. Toy rocket launched from a platform. The height of the rocket's modeled by this equation here that we have, where h is your height in meters above the ground and t is your time in seconds since the rocket was launched. When, so we're solving for t, did the rocket hit the ground? So if it hit the ground, at the moment it hit the ground, height is equal to 0. So it's time we're trying to solve for, and height is 0. So we're going to sub 0 in where the height is, or where h is. And then we have our quadratic equation that we need to solve. So identify your A, B, and your C. Put it in your quadratic formula. This is decimal numbers. You don't want to try and factor that. So use your quadratic formula here. All right, your A value should be negative 4.9. Your B should be 8.1. And your C is 3. And I wrote 2. There we go. C is 3. So x, or in this case, I'm not going to use x. I'm going to put t because it's time we're solving for. Time equals negative b plus or minus square root b squared minus 4 times a times c, all divided by 2a. All right, so there we have that, and then it's just a matter of putting that in your calculator and solving, which I have done here in terms of calculated under the square root sign, and then we're going to get our 2 times, one being negative 8.1 plus the square root of 124.41, all divided by negative 9.8, or we have our other time where we have the minus square root of 124.41 divided by negative 9.8. All right, and I've calculated those. Just remember that in this context, in the story, the negative time doesn't make sense. We can only have a positive time, so it must hit the ground at the 1.96 seconds. And magically we have that written down. So part B, it's asking for time again. At what time, so T is unknown here, we're solving for it, did the rocket have a height of 6 meters? So our height is 6. So instead of replacing height with 0, this time we're going to replace the height with a 6. So we're going to end up with 6 being equal to negative 4.9 T squared plus 8.1 T plus 3. And then before we can solve that, we have to get 0 on one side of the equal sign. So we're going to subtract 6 from both sides of the equation. And then when we do, we have negative 4.9, which is our A value, plus 8.1t, and that 4.1, of course, multiplies t squared. And then we have a minus 3 here. So you can go ahead and solve that using the quadratic formula, and then you can check your answers with mine. And for this one, I get 2 answers as well, but both are positive this time, and that is because it's going to be a height of 6 meters at 0.56 seconds on the way up, and then it's going to be at 6 meters again at 1.09 seconds on the way back down. So hopefully that makes sense, and good luck with your work.